Wow, that's really easy. You're going to say, oh, despite your best efforts not to, you're going to go, oh. Okay, now, let's just look at a couple things, okay? What is the mass of a proton? 1. What's the charge of that proton? +1. Okay? You get it? Okay, so in other words, when I said to you before, hydrogen had a mass number of 1 and an atomic number of 1, this subscript is actually +1. But we don't put that in. But it's actually +1. Okay? As opposed to +2, it's always +1. But we never put that in. But that's actually the charge, the subscript. So for instance, if I have carbon, 24 nucleons, 12 nucleons, and 6 protons. Do you get that? But we never do that. That's never done. Okay? All right? So that's a proton. What would an electron be? -1. What's the mass? 0. It's considered, it's 1,000th of a proton, so it's considered 0 though. It's considered massless. Okay. So, but the charges are equal and opposite, aren't they? Yes? So let's say I take something like sodium, something simple, okay? Let's look at sodium. And it's 23 and 11. I'm going to leave the plus sign there just for now. Is that okay? Okay. Now, in terms of ground state, what's ground state mean? What does ground state mean?
The electron goes back to its lower energy level.
Protons, you know what that means? It means number? Number? Or is that like an American thing? Is that like an American thing? Does it mean number to you?
Yeah, it means number.
Okay, so number of protons equals number of electrons, that's ground state. Ground state means a lot of different things, okay, fair enough. But they're equal, okay? So what would the charge of a ground state atom be? What would the charge of a ground state atom be? Neutral, it'd be 0. 0 charge, right? Because the number of protons equals the number of electrons. They're both 11, correct?
Yep.
Now let's say we react sodium. So remember we said, what defines stability on the periodic table? Look at a periodic table. What defines stability on a periodic table? We've done all this. Should I make a periodic table? I don't know how much time I have left on my... Okay, I'm not going to make the F series. Okay, is that all right? I'm just going to make up here. Okay, so this is 9 each. Okay, and then this will be 4. So 1, 2, 3, right? 1, 2, 3, and then 1, 2, 3, 4, 5. No, 1, 2, 3, 4, sorry. 1, 2, 3, 4. Okay, we'll make our columns now. Make sure I have 18. Did I do that wrong? I'll just put a couple on the end if I did. I would love my kingdom for a periodic table for the wall. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. A little weird, I got that right. Okay, and then 7 rows. We're not doing the F's. 2, 3, 4, 5, 6, 7. Okay? And then we'll erase this. So we can erase this, right? To here?
Yeah.
Right? And then down to here, right? Is
Yeah.
that right?
No.
Nope! What did I do wrong?
You need like 1, 2, and then erase it 3 as well.
Okay, so this should be, sorry. Okay. And then over to here, I can erase this. 1, 2, 3, 4, 5, 6, so I can erase this, right?
Mr.
Yeah, what did I do wrong?
It's here.
What?
You didn't erase like the third one.
I can erase the third one.
Yeah, and then down to like the third period, you erase it as well.
Yeah, no, I know, that's what I was doing. But I thought you said, no, I can't do that.
Oh, you erase the third group as well.
What?
Yeah.
Yeah, what are you saying? What are you trying to say to me? I want to get, oh, you mean I erase this one?
Yeah.
Oh, no, I know. I was doing that, but I thought I thought you said I erased the horizontal line I shouldn't have erased. Oh, I'm sorry. Okay, well done. All right, so 1, 2, 3, 4, 5, 6, right? So then I can do that, then that, right? Right? Is this right? Am I okay? 1, 2, 3, 4, 5, 6, right? Is easy. And then I have the 2 in the bottom, but I don't care about those right now, all right? Okay? All right, so in other words, here's sodium, right? Atomic number 11, mass number of 23. I was thinking 23 at the same time I was writing the end of the 2. So, to be like the nearest, yes?
Can we round up mass number?
What?
Do we have to write exact number or round?
Mass number's fine. Mass number's fine. If you always use mass numbers, I'll explain that in a minute. So, where is the nearest noble gas to number 11? This is 2. This is 10. This is 18, right? This is neon, right? So, what? I'm sorry, Ne, right? So, do you see that it's only one away from being like that? So where it's still going to be sodium, it wants to have the same number of electrons as neon. Because what happens if it has the same number of electrons as neon? What happens? It has the same what? It has the same what? It has the same valence shell. You ready? Why is that important? Because it's the outer part of the shell that does the reaction. You see? So if the outer part of the shell is the same, in terms of the chemical world, it is the same. In terms of the chemical world, it's the same. It's not going to react anymore. It's going to be stable. It's going to think that it's neon. We won't tell it that it's not neon. But in terms of reactivity, it thinks it's neon. A little weird, okay. So therefore it's going to have how many protons after it reacts? How many protons will it have?
11.
11. It's still going to have 11 because it's still sodium, even though it thinks it's not sodium. It's still sodium, okay? It still has 11. It's like a name tag. Sodium, 11, okay? It thinks it's neon, but let's not say anything, okay? So it has 11 protons. How many electrons does it now have? Because it gave up one. How many does it have now? Can you count? Can you do simple math? I know this is DP chemistry, but it's 10 minus 1. What do you think? 10. Pretty good. Okay. So it has plus 11, and then it has minus 10. So, you ready? Higher math. Plus 11 minus 10. Add that together. What do you get?
Minus 1.
Really? You guys need, your problems have nothing to do with chemistry. Trust me. Plus 11, combine that, add that to negative 10, what do you get? Plus 1. That's a little scary. That's where the charge comes from, Ling Ling. After it reacts. Let's look at chlorine. Chlorine's over here. It's 7 17, that's its mass number.
Yeah.
Or its atomic number. Okay, it's atomic number, 17. Yes?
So it becomes ion after it has charge?
It what, huh?
It becomes ion?
It becomes ion, absolutely.
Wouldn't it be
Absolutely.
a cation?
It's a cat, no, cat ion, as opposed to a dog ion. It's cat ion.
Oh, the other one, anion.
Huh?
Onion.
Anion is the negative charge. I'm being silly.
Yeah.
Anions are negatively charged, cations are positively charged. Okay? That's my terrible Russian accent. Okay, now, I used to teach entire classes in a different accent. That was weird. Okay. Yeah, and I'm normal now, right? Okay. So I'm gonna, it's gonna be, chlorine is gonna be, what is it, like 35 and 17, right? So it has 17 protons, correct? So if it wants to be like the nearest noble gas, which is what?
Argon.
Argon. How many electrons does argon have? 18. So now it has 18 electrons. So what's its charge going to be?
Negative 1.
-1. See, this isn't accounting where, you know, it has a +1 electron. It has an extra electron. This isn't an accounting class, Ling Ling. This is a chemistry class. We're looking at charge, not like debits and credits. That's what you're thinking. I know that's what you're thinking. Okay? Well, tell Mr. Jeff, you know, to keep his debits and his credits to himself. Okay? And I said that. And say, you know, all right? So this is we're looking at charges, not debits and credits. Yes? So it has a charge of -1 because of the extra electron. This row will always be -1, the whole row. This row will be -2, -3. This will be plus or -4. Right? This will be +3. This will be +2. This will be +1. Okay? These will have varying ones because there's other things involved there.
The last
What's that like the periodic?
This one? This one? That doesn't have a charge because they don't react. They don't lose. Well, these will react. We don't really know what this one is, but these will react a little bit, like xenon. Okay. Whatever we just did, we're finished. What did we do? We looked at charges, okay?
Electromagnetic.
Like oxidation numbers, we looked at, okay?
Mr. T, for the deep block, there are the metals, right?
They're metals,
And then they don't
mostly.
And they don't lose electrons easily.
They what?
Do they want to become stable as well?
They're already pretty stable. Some of them are not.
So that's why they don't give out or accept electrons.
No, they'll give up electrons because they're metals. I mean, they give up metal. They give up electrons to bond. But some of them are more stable than others. Gold is very stable, for instance. That's why it's so shiny for thousands of years. It'll stay like shiny. It'll get a little dusty, but it won't get an oxide on it. Okay. Or a sulfide. You know, you get like a metal oxide will coat. You know, like silver gets a tarnish. Okay, that's a sulfide coating, right? All right, talk to you later. Bye, guys.